Hello and welcome to Spy Math. This is Mr. Spy, and this will be part 3 of August 2018 Geometry Regents. Question 32. Given triangle ABC with segment AEC and segment BED with angle ABE congruent to angle CBE and angle ADE congruent to angle CDE. So let's mark off those given angles. So ABE same as CBE, and ADE, same as CDE. Prove that BDE is a perpendicular bisector of AC, so that this segment is the same as this, and then there's a right angle right over there. This proof wants you to fill in the missing statements below. So the first blank that's missing is 2. It says BD is congruent to BD. That is a classical use of the reflexive property. Anytime you use the same thing on both sides of the reflexive property. Supplements of congruent angles are congruent. So if you look at choice 3, we have 2 supplements. So you can use BDA and BDC, or you can use ADE and CDE. Now, the next statement, it follows after a congruent triangle theorem, in this case angle side angle, always follows with CPCTC. And BDE is a perpendicular bisector of AC. In this case, they want you to find the word perpendicular bisector and to use the fact that these segments are equal to show that's a perpendicular bisector. So here is the 4 steps typed out. So by 2, reflexive property. This 4th statement is angle BDA is congruent to angle BDC. 6 is CPCTC, which stands for corresponding parts of congruent triangles are congruent. And 7, which is a long one, point B and point D are equidistant from points A and C, which are the endpoints of segment AC. Therefore, points B and D are on a perpendicular bisector of AC, since all points on the perpendicular bisector are equidistant since all points on the perpendicular bisector are equidistant are these points that form the endpoints of that segment. Sorry for the typos in that statement. On to question 33. A homeowner is building 3 steps leading to a deck, as modeled by the diagram below. All 3-step rises, segment HA, segment FG, and segment DE are congruent. And all 3 steps run segment HG, segment FE, and segment DC are congruent. Each step rise perpendicular to the step running joins. The measure of angle CAB equals 36 degrees. The measure of angle CBA equals 90 degrees. And they give you this diagram. And each step run is parallel to segment AB and has a length of 10 inches, making a total of 30. 3 steps, 10 times 3 is 30. Determine the length of each step rise to the nearest tenth of an inch. So let's draw one triangle separately. In this case, I drew triangle AHG separately. We have HG as our adjacent side, which is 10 inches. We have the x, the value of HG we want to find, as our opposite, so that's tangent. So tangent of 36 equals x over 10. Cross multiply, x equals 10 tangent 36, which is 7.3 inches. Just to show you, each step rise is probably 7.3 inches. Okay? And determine and state the length of AC, which is the hypotenuse in the major triangle. and 30 is the adjacent side, making it cosine 36 equals 30 over y. Anytime y in the denominator you divide, so 30 over cosine 36 is approximately 37 inches. So AC is 37 inches to the nearest whole inch. Make sure that part B is to the nearest inch, part A is to the nearest tenth of an inch. Let's just go over what the calculator will look like for this. So for the first part, 10 times tangent of 36. Also make sure your mode is right mode, degree. 10 tangent 36 is 7.26. So let's say your calculator is in the wrong mode. Let me show you a cool trick. So 30 divided by cosine 36. It's second apps. Go to the first symbol, which is a degree symbol. Even in radians, this will work. Close the parentheses, and you get 37.08 or 37 inches. Let's continue. On to question 34. A bakery sells hollow chocolate spheres. The large diameter of each sphere is 4 centimeters, so let's just write the radius immediately. So if the diameter is 4 centimeters, the radius is 2 centimeters. The thickness of each chocolate is 0.5 centimeters. That's 0.5 centimeters on each side of the sphere. So we take away 0.5 centimeter of 2, we get 1.5 centimeters. So to say to the nearest tenth, simply the amount of chocolate in each of the hollow spheres. So if it was 4 centimeters, and we take away half a centimeter on each side, we are left with 3 centimeters in that sphere. Remove that bad drawing, and let's calculate our calculation. So the volume of each chocolate sphere is 4/3 pi r cubed is our formula we're using. The volume of the sphere, 4/3 pi r cubed. So the outer sphere is 4/3 pi 2 to the third power minus the inner sphere, 4/3 pi times 1.5 to the third power is approximately 19.4 centimeters cubed. Now on to the second part. Bakery packages 8 of them into a box. The density of the chocolate is 1.308 grams per cubic centimeter. Determine and state the nearest gram total mass of the chocolate in the box. Since the density is given 3 decimal places, be careful to use 3 decimal places in almost every single step. So density equals mass over volume. So you do a little change of that equation. Mass equals density times volume. Our volume is 19.4 centimeters cubed. Our density is 1.308 grams per cubic centimeter. We do 19.4 times 1.308 to get the mass. The mass is 25.3 grams. We have 8 of them. 24.53 times 8 is 203 grams. Okay. Just to show you what this looks like on the calculator before we finish. So to find the volume in the calculator, hit alpha y equals option 1 to type in that fraction. So 4/3 pi is second exponent symbol, parentheses, 2 exponent symbol raised to the third power, minus alpha y equals, first option, 4/3 times pi times 1.5 to the third power. Oops, an extra parentheses, delete that. Is 19.4. Then you take the 19.4, so it's second answer, you don't want to round, times it by the density, 1.308, times it by the 8 chocolate spheres, and you get 202.7 2, which is exactly our answer, 203 grams. Thank you for watching. This is Mr. Spy, signing off.